everybody. My name is Marissa, and I have a bachelor's degree in mathematics with a minor in statistics. In today's lesson, I will discuss why paired t-tests are used, as well as how to conduct a 5-step hypothesis test for the population mean of paired differences. Let's imagine that we own a personal training business, and we want to see how much weight a sample of our clients are losing with an exercise program. In order to test the effectiveness of our program, it would make the most sense to compare each client's weight before and after the program, rather than comparing their mean weight to a specific value. While traditional t-tests compare the mean of a sample to a predetermined value, a paired t-test compares each sample to itself. Other examples where a paired t-test would be used include testing the scores of students before and after a new study program, and measuring a patient's blood pressure before and after a medication. Going back to our personal training example, let's say that we want to test whether or not our clients are losing a significant amount of weight. In order to do this, we must conduct a 5-step hypothesis test for the population mean of paired differences. The first step of this process is determining our null and alternative hypotheses. The null hypothesis is always in the form of mu of d equals 0, meaning the mean of our paired samples is the same before and after a treatment. In the context of our personal training example, the null hypothesis in words would be there is no difference in weight before and after training. The alternative hypothesis can be one-tailed or two-tailed. One-tailed hypotheses can be left-tailed or right-tailed. For example, if we think that our clients will lose weight during their personal training sessions, we would use a left-tailed alternative hypothesis, which is denoted with a less than sign. Now, let's say that we had clients that wanted to gain weight and muscle rather than lose body fat. This would be a case where we would use a right-tailed test, which uses a greater than sign. Lastly, if we wanted to say that our personal training sessions result in a change in weight, either gained or lost, we would use a two-tailed test, denoted using a does not equal sign. After we set up our hypotheses, it is time to calculate the test statistic t. Note that there are two formulas for calculating a t-test statistic. The first formula, t equals x bar minus mu divided by s over square root n, is incorrect when used with paired data. The correct formula is t equals d bar minus 0 divided by the standard deviation of d over the square root of n. The d in this formula stands for difference. The d bar in the formula is found by adding all differences and dividing by the number of differences. The standard deviation of d is found by taking the square roots of the sum of all differences minus the mean difference squared and then dividing by n minus 1. When calculating a t-test statistic for paired differences, we must first compute the differences if not given to us. We do this by simply subtracting the before value from the after value. After we have our differences, we can compute d bar using our formula. This gives us a value of negative 3.6. We now need to calculate the standard deviation of d. Using our formula, we take the square root of the sum of all values of d minus d bar squared and divide by n minus 1. This gives us a value of 29.2 over 4, which gives us 7.3. Taking the square root, we get a standard deviation of 2.7. Now that we have all values needed to calculate t, we now simply plug in our values for d bar, standard deviation of d, and n, and obtain a t-test statistic of negative 2.98. In order to determine if our clients have lost a significant amount of weight, we must compare our test statistic to the critical value. Please note, this result can also be obtained using the p-value method, but we will not be covering this in today's lesson. To find the critical value, we will use a t-table, which is found in the back of most statistics textbooks. Using the table, we must first calculate our degrees of freedom, which is simply the sample size minus 1. So, if we have 5 clients, we would use 4 as our degrees of freedom, which we find in the rows of our t-table. Now, we need to find our alpha value in the columns of the table. Alpha represents the probability of obtaining our results by chance and is assumed to be 0.05 unless specified otherwise. If the test is two-tailed, we halve the value of alpha and use both the negative and positive version of the critical value, giving us a value of plus or minus 2.776. If the critical value is more than the positive critical value or less than the negative critical value, we reject the null hypothesis. If the test is right-tailed, we would simply find the value of alpha on the t-table, and that will be our critical value, 2.2132. If the test is left-tailed, the test we are using for this example, we use the same process, but we would put a negative sign in front of the value, giving us a value of negative 2.132. If the test statistic is less than the critical value, we reject the null hypothesis. If the test is left-tailed, the test we are using for this example, we use the same process, but we would put a negative sign in front of the value, giving us a value of negative 2.132. If the test statistic is less than the critical value, we reject the null hypothesis. Any value beyond or below the critical value or values are known as being in the rejection region. Because our t-statistic, negative 2.98, was less than our critical value, negative 2.132, we reject the null hypothesis. Because we rejected our null hypothesis, we would say, reject the null hypothesis. We can conclude that weight decreases after personal training sessions. However, if we did not reject the null hypothesis, we would say, fail to reject the null hypothesis. We do not have enough evidence to support the claim that weight decreases after personal training sessions. Great job, everyone! Today we learned about why we use paired t-tests. We also learned about how to conduct a 5-step hypothesis test for the population mean of paired differences. Thanks for watching, and please be sure to check out other videos about statistics lessons and applications here on Chegg.